For number 5, I noticed that the degree of the numerator and the degree of the denominator are the same. So what I'm going to do is use long division to break this fraction up, and maybe it'll be easier to integrate from there. 8x squared divided by 4x squared is 2. Now we multiply the divisor by 2 and get 8x squared, and 3 times 2 is 6. Draw your line and change your signs. Now what we have here is just a plus 0. So 8x squared plus a negative 8x squared is 0. 0 plus a negative 6 is negative 6. So my remainder is negative 6, and that can be written over the divisor. Now we have turned this one fraction into two parts, which means that integrating 8x squared over 3 plus 4x squared is the same as integrating 2 minus 6 over our divisor. And you can actually separate your integrals, and this I can integrate right now. That is 2x. What about this? This looks very similar to the integral formula for arctan. So let's take a look. This would be u squared because it's a function of x, and this would be a squared, which would make u the square root of 4x squared, making u prime 2, and a is the square root of 3. So you need to have u prime in the numerator, which is a 2. Right now in the numerator we have a 6, so I'm just going to factor out 3. And now we should have the form that we need to integrate. This is equal to 1 over a arctan u over a plus c, which simplifies to be this, and I think 3 over root 3. If you rationalize the denominator, it actually does make it a lot simpler looking. 3 root 3 over 3, that's just root 3. So 3 divided by root 3 is the same as root 3. And I think that is the cleanest version, or the most simplified version of that. Number 6 looks very similar to the arcsine integration formula, except that if u is equal to the square root of this, so if u is equal to x, then u prime is equal to 1, and we have an entire x plus 4 on the top. So, if it was just 4, then I could use the arcsine formula. So what if I actually split this fraction up so that now I'm integrating x over the denominator square root 4 minus x squared, plus I'm integrating 4 over its denominator 4 minus x squared. So like I said, if it just had 4 in the numerator, then I could use the arcsine formula, because I'm going to take that 4 out of the numerator so that 1 is here. Okay, looking at this integral, a squared is 4, so a is 2. U squared is x squared, so u is x, and u prime is 1, which is our numerator. Great. So this would be plus 4 times arcsine u over a, x over 2, or 1/2 x, plus c. Awesome. Okay, so we got that part of the integral, but we still need to integrate this, and this is not in the form of the arcsine formula. So maybe it's time to think back to some of our older integration techniques. Previously, when we had a square root, we made the thing that was under the square root equal to u. So I will try that. U is equal to 4 minus x squared, which would make du dx equal to negative 2x. Okay, so we have an x up here, not a negative 2. So if we could put a negative 2 into the numerator, then we would have some u substitution that we could simplify. Let's try that. To put a negative 2 in the numerator, I will need to multiply by a negative 1/2 outside of that integral. So I will have negative 1/2, and I'm going to actually do the u substitution so you can visually see it. This would be 1 over root u du, or du over root u. That makes my life a whole lot easier because I can write it as u to the negative 1/2 du. Remember, we still have a plus 4 arcsine x over 2 plus c. Now, it's not correct to have part of your answer in terms of u and part of your answer in terms of x, but we'll get there. We'll get to our answer fully in terms of x. So this would be negative 1/2 times the integral u to the negative 1/2 is u to the negative 1/2 plus 1, which is positive 1/2, over that number, which is positive 1/2. And now we drop the 4 arcsine x over 2 plus c. Negative 1/2 divided by 1/2 is just negative 1 times u to the 1/2, or square root of u. In terms of x, this would be square root of 4 minus x squared plus 4 arcsine x over 2 plus c. Now I have completely integrated all in terms of x. For number 7, complete the square to find the integral of this. Okay, so in the denominator I have x squared plus 4x plus some number. Remember, to complete the square, your c value, or the constant, needs to be half of this number squared. 4 divided by 2 squared. That is 2 squared, which is 4. So 4 is what should be here, not a plus 8. So I'm going to add 4, but I can't just add 4. I have to also subtract 4 in the same exact spot. That way I'm only adding 0 to the denominator. So I have my perfect square trinomial, and then I have the constants that are not part of it. So negative 4 plus 8 is positive 4. Now, you could have automatically seen that 8, in order to have a plus 4, we could have just changed 8 to, instead of being plus 8, plus 4, because that is the same as plus 8. So doesn't matter either way, however you algebraically want to manipulate it so that you have a perfect square trinomial. And now we do. So we're going to write it as a binomial squared, x plus b over 2, remember, so that would be 4 divided by 2 squared, and we just have a plus 4 in the denominator, and now we have something that looks a lot like the integration rule for arctan. Let me show you. You have a function of x being squared, that would be u. You have a constant being squared to get 4, so that constant would be 2, the square root of 4, and u prime is 1, and that's in your numerator. So 1 over 2 times arctan of x plus 2 over 2 plus c.